Hi everyone, this is a Math 082 video. This is 4.1, which deals with the greatest common factor. So overall in this chapter, we are going to be looking for a general factoring strategy for polynomials. So we can't really proceed any further with our steps until we learn how to factor out our greatest common factor. So that's what this section is going to teach us. And before we can do that, we need to answer the question, well, what do we mean by the phrase greatest common factor? Simply put, it is the largest term that can be factored out of a series of terms. And I use the word term instead of number because it could be a combination of numbers and variables. So you probably learned how to factor out a greatest common factor for a set of numbers. So we're just going to go back and review that. And one way to do that is a process called prime factorization, which means we factor numbers down to their primes, down until they can't be factored out anymore. So let's start with 15. 15 is 5 times 3. 5 and 3 are both prime numbers, so the tree can't branch out anymore. 27 is 3 times 9, and 9 is also 3 times 3. And again, 3 is a prime number. 36, we can start anywhere. We could put factor out a 2, a 3, a 9, 12. There's lots of different numbers that go into 36. Just for the sake of simplicity, I'll just pick 3. You probably know that 12 is also divisible by 2. 2 times 6 is 12, and 6 is 3 times 2. Okay, and those are our prime factors. Okay, so we're not done yet. We need to actually figure out, okay, well, what is our GCF? In other words, what is the largest number that all three numbers have in common? Okay, so what we're going to do is we're going to go through each tree and pick out the common things. So I see a 3 here, a 3 here, and a 3 here. It doesn't matter which of the threes you circle. So I'm going to put a 3. I see a 5 here, but no 5s here or here, so I can't include that. As you can see, I have exhausted this tree. Okay, there's nothing left over here that I haven't circled. So therefore, my GCF for this example is not very large. My GCF is 3. Let's do one more numerical example before we move on to terms that include variables. Okay, so as you can see, I have slightly larger numbers that I'm working with here. So 54 is 6 times 9. 9 is 3 times 3. 6 is 2 times 3. 36, we'll just do it differently this time, just for fun, just to change it up. Okay. And 18, you can pick any number you want to start with. You're going to end up with the same prime factorization. All right, so let's start building our GCF. So I'm going to start with over here. I see a 2 here, I see a 2 here, and I see a 2 here. Right? Think about the word common. What does the word common mean? It means something that everybody shares. They all have a 2 in common, so I'm going to build 2 into my greatest common factor. Okay, then I see a 3 here, a 3 here, and a 3 here. They all share that 3. They have a 3 in common, so that's going to be built into my greatest common factor. Okay, let's keep going. I have another 3, another 3, and another 3. Okay, so that's going to be part of my greatest common factor. At this point, you will notice that I have exhausted all of the prime numbers over here. 18 is done. There are no more factors. And in fact, if you multiply 2 times 3 times 3, you find out that your greatest common factor is 18. Notice that your greatest common factor cannot be larger than your smallest term. Okay, it has to be less than or equal to your smallest term that you're trying to find a greatest common factor for. So let's keep going and look at variables. So remember when we have exponents, This is just a shorthand way of expressing multiplication. So even though it might seem a little strange, I can actually rewrite these as a product, right? So x is just x squared is x times x, and x cubed is x times x times x. So just like I did with the numbers, I can go through and find the greatest common factor. So they all have one x in common, okay? And again, at this point, I have exhausted this tree. There's nothing left. So in this case, my greatest common factor is x, okay? And remember, your greatest common factor has to be less than or equal to your smallest term. Okay. So let's look at these. So let's say we have x to the 5th, x to the 10th, and x squared. Now, if I wanted to, I could go through and I could look at these. I could rewrite them as multiplication. So I'll do that for the first one. I won't do that for the rest of them. So x to the 5th is 1, 2, 3, 4, 5 x's. Okay, so that's my tree. So let's erase this so we have a little bit more room here. Okay, x to the 10th power, 1, 2, 3, 4, 6, 7, 8. Wow, this is hard to do and count at the same time. Is that 10? I feel like that's 10. Okay, and then we have x squared is x times x. Okay, so as we build our GCF, okay, we can take one x from each place, so that gives us an x. We can take another x from each place. Okay, and again, at this point, we've exhausted our smallest term, so our GCF is x squared. Now, hopefully you can see that there is limited utility here in trying to go through that every time. So a better option for us is to use the fact that the GCF, when you're working with variables, is going to use the smallest exponent shown. Okay? So what we can do to find the GCF is literally just circle the term with the smallest exponent. So in number 1, x squared is the smallest exponent. Take a second and see if you can do number 2 without me. Did you say x to the 17th? If so, that's correct. That's the GCF. How about number 3? We have x, x cubed, x to the 7th, and x to the 10th. So our GCF is the smallest exponent of x, which is x. All right, let's do 2 more examples. So we want to find the GCF of 24x cubed y and 18x y squared. So this is our first example that has contained both numbers and variables. So what we need to do, or one way to approach this, is to do a prime factorization tree of our number. So I'll do that really quickly. Okay, and then we can do one of 2 things with the variables. With the variables, we can either remember that rule of picking the lowest exponent, or we can write it out longhand. So just this once, let's write this out. X times x times x times y, just to visualize it, okay? And then for subsequent problems, we won't do that. We'll just use that rule of thumb. Okay, and this is x times y times y. All right, so let's go down here and build our GCF using our trees that we've generated. So I see a 2 here and a 2 here. That is a factor that they have in common, so I'm going to add that. I see a 3 here and a 3 here, so that also goes here. What else do we have? I see 1x here and 1x here, so that gets built in. We have 1y and 1y here, so I'm going to put a y there. Okay, let's see what else we have. Let's see if we can find anything else that we have in common. I have a 2 here, but I don't have any more 2's over here to contribute to the pot. I have another 2 here, but again, no more 2's. I have an x here, but I don't have a matching x over here. I have another x over here, but again, nothing over here to match it. Likewise, over here, I have a 3. Oh, I already used that color. Let's use a different color. How about this one? Okay, I have a 3 over here, but I don't have a 3 over here to match it, so it can't go. It's not something they have in common. Okay, and likewise, I have a y over here, but I don't have a y over here to match it. So none of those other terms can be built into our GCF. Okay, so our GCF, 2 times 3 is 6. So our GCF is 6xy. Let's do one more of these, and then I'll end the video. So this time we have big numbers. We have 72xy to the 5th. So we can factor that. We get 9 times 8. And 8 is 2 times 2 times 2. 9 is 3 times 3. 18 is 2 times 9, just 3 times 3. This time, I'm not going to factor out the exponents. I'm simply going to use my rule of thumb, which is to think about which of the two variables has the lowest exponent. All right, so let's go through and circle our numbers. So I have a 3 here and a 3 here, so that goes into the pot. I have another 3 here and another 3 here. That goes into the pot. And then I have a 2 here and a 2 here. Okay, that goes into the pot. You might have also proceeded by observing that 72 is divisible by 18 and therefore concluding that 18 is your GCF. That is also a valid way to proceed. Okay, so let's look at our x's. So I have an x to the first power here and x to the third power here. So between x and x to the third, which of those two has the lowest exponent? If you said x, that's correct. Okay, how about this one? We have y to the 5th and y to the 4th. Between those two options, which one has the lower exponent? Okay, y to the 4th has the lower exponent, so that goes into our GCF. So 3 times 3 times 2, mentioned earlier, is 18. So our GCF is 18xy to the 4th power.